This is not just an asteroid. It may be the exposed metal heart of a world that never survived. NASA's Psyche spacecraft just used Mars as a slingshot. That move quietly changed the next decade of asteroid science. The target is called 16 Psyche. It sits in the main asteroid belt between Mars and Jupiter. Most asteroids are rock, ice, or rubble. Psyche appears unusually rich in metal. That is why scientists care. It may let us study a planetary core without drilling through a planet. Earth has a metal core too, but it is hidden under thousands of kilometers of rock. Psyche could be a shortcut into a chapter of planet formation we almost never get to see. If it is a stripped core, something violent happened early in the solar system. If it is not a stripped core, that may be even stranger. Either way, this object is a fossil from the construction site of planets. The mission is not about mining treasure. It is about asking what planets are made of before they become planets. And after the 2026 Mars flyby, the spacecraft is finally on the road to the mystery. On May 15, 2026, Psyche skimmed past Mars instead of stopping there. That sounds backwards until you understand gravity assists. The spacecraft borrowed a little motion from Mars to reshape its path around the Sun. It did not need a giant fuel burn. The planet did part of the work. NASA said the flyby brought Psyche within only a few thousand miles of the Martian surface. From Earth, that is a narrow target. In deep space, it is threading a needle at planetary speed. The spacecraft also captured rare views of Mars from an angle humans almost never see. Those images were not the main mission, but they became a preview of the spacecraft's eyes. Mars was the door. Psyche is the room behind it. The same flyby also tested navigation, cameras, and deep space communications. Every clean maneuver reduces uncertainty before the real arrival. Now the probe is aimed for an August 2029 encounter with the metal world. Metal is not rare in space, but a large metal-rich worldlet is rare enough to change the questions. Planets like Earth separated into layers when they were young and hot. Heavy metals sank inward. Lighter rock rose outward. That process made cores, mantles, and crusts. But we cannot watch Earth do that now. The experiment ended billions of years ago. Psyche may preserve evidence from that violent beginning. A collision could have torn away an early world's outer layers. What remained may have cooled into the strange object we see today. Or Psyche may be a different kind of mixed body, not a clean core at all. That uncertainty is the point. The mission is designed to test the story, not assume it. Gravity, magnetism, surface chemistry, and images will all matter. The asteroid is not the answer. It is the crime scene. While Psyche was heading outward, humans had just returned to lunar deep space. Artemis II flew around the moon in April 2026. For the first time since Apollo, a crew left Earth orbit and saw the moon up close. The images were not just symbolic. They showed far-side terrain, Earthrise, and eclipse geometry. The crew also photographed regions no human eyes had seen from that perspective before. That matters, because the moon is becoming a proving ground again. Not for flags alone. Navigation, power, communications, landing systems, and survival. Every lunar mission is now tied to a larger architecture. The moon is a destination, but it is also a test range. The old space race asked who could arrive first. The new space race asks who can stay, operate, and build. That is a very different kind of victory. The lunar far side is often imagined as a blank gray wall. It is not. It is cratered, fractured, ancient, and scientifically loud. Artemis II's flyby turned that hidden terrain into a human observation target again. Craters record impacts. Lava flows record heat. Fractures record stress. The moon is not alive like Earth, but it remembers violence extremely well. During the flyby, the crew also watched eclipse conditions from space. That gave scientists a rare angle on the sun, moon, and Earth lining up. Even a short flyby can produce thousands of useful images. Those images help plan future landing zones and future hazards. The far side also matters for radio astronomy, because Earth is blocked there. One day, the quietest observatory near Earth may sit on lunar ground. The moon is familiar in the sky, but close inspection keeps making it stranger. A few years ago, humanity deliberately hit an asteroid moon. DART changed the orbit of Dimorphos around Didymos. But impact was only half the experiment. ESA's Hera mission is the follow-up detective. Hera is traveling to measure the crater, the mass, and the internal structure of the target. In 2026, Hera performed deep space maneuvers that kept it on course for that rendezvous. That matters, because planetary defense is not a movie genre anymore. It is becoming an engineering discipline. If we ever need to move a dangerous asteroid, details will decide everything. Is it solid rock, loose rubble, or a strange pile held together by gravity? A push that works on one object could fail on another. Hera is how we learn the difference before the stakes are real. The scary part about asteroids is not only size, it is warning time. A small object found early can be managed. A small object found late can be chaos. Recent close approaches keep reminding astronomers that the sky is not fully cataloged. Most near-Earth objects are harmless, but harmless still has to be proven. That proof comes from repeated observations across days, months, and sometimes years. A single dot in a telescope image is not enough. Scientists need an orbit, uncertainty ranges, and follow-up measurements. Sometimes a risk appears, then disappears as better data arrives. That is not panic. That is the system working. The public sees a headline. Astronomers see probability shrinking. Planetary defense is mostly patience, math, and better telescopes. The real win is finding the object before it becomes news. While the moon and asteroids dominate headlines, Europa is quietly waiting. NASA's Europa Clipper is on a long route toward Jupiter's icy moon. Europa may hide a global ocean beneath its cracked surface. That makes it one of the most important places in the search for habitable environments. The mission will not land. It will fly by again and again. Repeated flybys can still map ice, chemistry, thickness, and possible plumes. Spacecraft used Mars earlier in its journey and is scheduled for an Earth gravity assist in 2026. That long path is necessary because Jupiter is brutally far away. Europa is not just a moon, it is a locked box. The key is not one instrument, but many instruments asking the same question. Could an ocean world have the ingredients life needs? Clipper's going there to make that question much less vague. People talk about Mars like it is a single heroic leap. In reality, Mars is a supply chain problem. You need launch vehicles, landers, habitats, suits, power, communications, and rescue options. That is why the moon keeps coming back into the plan. It is close enough to test systems and far enough to be unforgiving. A lunar base is not automatically a Mars base. But lunar operations can reveal what breaks before astronauts are months from Earth. The new architecture is less about one rocket and more about many connected systems. Commercial landers, government spacecraft, relay networks, and surface equipment all have to cooperate. That makes the future messier than Apollo, but potentially more durable. The first permanent steps beyond Earth may look industrial, not romantic. That is how exploration becomes infrastructure. Another race is happening closer to home. What replaces the International Space Station? Low Earth orbit is no longer only a government laboratory. Companies are planning private stations, free-flying modules, and commercial research platforms. That shift could change who gets to work in orbit. The question is not whether humans can live in low Earth orbit. We know they can. The question is whether orbit can support a real economy without one giant public station. Microgravity research, manufacturing, tourism, and national programs may all share the same neighborhood. But space stations are expensive, fragile, and unforgiving. A business plan is not life support. The winners will need engineering discipline, launch reliability, and customers who return. If it works, Earth orbit becomes a staging area instead of a finish line. That would quietly change the entire map of human spaceflight. The old space race had two superpowers and one obvious finish line. The new one has nations, companies, science teams, defense agencies, and commercial investors. The finish lines are different depending on who is running. For NASA, it is Moon to Mars, exploration and science return. For ESA, it includes planetary defense, science missions, and independent capabilities. For India, China, Japan, and others, lunar success is strategic as well as scientific. For companies, the prize may be launch cadence, station access, data, or cargo contracts. That makes the race harder to explain but more important to watch. No single launch tells the whole story. The pattern is in the infrastructure being built behind the dramatic moments. Who can repeat missions, lower costs, and recover from failures? That is who shapes the next era. The honest version of space science includes a lot of uncertainty. We do not know exactly what Psyche is. We do not know how common ocean worlds with habitable chemistry really are. We do not know which asteroid structures are easiest to deflect. We do not know whether lunar resources can be used at useful scale. We do not know how humans will handle long Mars missions physically and psychologically. That is not a weakness. It is the reason missions exist. Every spacecraft turns a question into measurements. Every measurement kills some theories and strengthens others. The public often wants the discovery headline. Scientists usually want the uncertainty to get smaller. That slower process is where the real breakthroughs hide. The reason 2026 feels different is that many threads are moving at once. Artemis 2 proved crewed lunar deep space flight is back. Psyche's Mars flyby pushed a metal world mission toward its target. Hera kept closing in on the asteroid system humans already changed. Europa Clipper continued its gravity assist path toward an ocean moon. Commercial stations and lunar cargo systems are trying to turn plans into hardware. None of these stories is the whole future alone. Together, they show a solar system becoming operational. Space is moving from rare spectacle to overlapping campaigns. That is why the next decade may feel faster than the last one. The discoveries will not arrive in a straight line. They will arrive as a network of missions, finally reaching their targets. Psyche will not answer everything when it arrives. It will begin by mapping, measuring, and slowly tightening its orbit. The first images may look confusing instead of clean. That is normal. New worlds rarely match the simple version in our heads. Scientists will look for metal, rock, craters, magnetism, and clues to ancient heat. If Psyche is a core, it is one of the strangest fossils ever visited. If Psyche is not a core, then the solar system found another way to surprise us. Either answer is valuable. Meanwhile, the Moon, Mars, Europa, and asteroid defense will keep moving. The story is not one destination anymore. It is a whole map waking up at the same time. And that is why this is not just an asteroid. It is a sign of where space exploration is going. The next space age will not be defined by a single footprint. It will be defined by routes. Routes to the moon, routes past Mars, routes to metal asteroids, routes to ocean moons, routes that protect Earth from rocks we used to simply fear. That is a bigger story than one mission or one agency. The solar system is becoming a place with traffic, infrastructure, and strategy. Some missions will fail. Some will arrive late. Some will reveal things nobody predicted. But the direction is now clear. Humanity is no longer just looking up at the solar system. We are learning how to move through it.